question number 2 is describes clamper. So, a clamper is an electronic circuit that fits either the positive or the negative peak accretions of a signal to a defined value by shifting its DC value. The clamper does not receive the peak-to-peak accretions of the signal. It moves the whole signal up or down so as to place the peaks to the reference level.
Question number 4 is what is inverse clamping? The inverse clamping is where the diode is connected in the opposite direction. For example, this is negative clamper. During the positive half cycle, the input diode is in forward bias, and as the diode conduct, capacitor get charged. During the negative half cycle, reverse does not conduct and the output voltage become equal to the sum of the input voltage and the voltage stored across the capacitor. This is the diagram for the positive clamper. In the positive clamper, it is almost similar to the negative clamper circuit, but the diode is connected in the opposite direction. During the positive half cycle, the voltage across the output terminal become equals to the sum of the input voltage and capacitor voltage. During the negative half cycle of the input, the diode start conducting and charges the capacitor rapidly to its peak input value. Thus, the waveform are clamped toward the positive direction as shown before. Question 5. Explain the clipping with Zener diode. So, the use of a bias voltage means that the amount of the voltage waveform that is clipped off can be accurately controlled. But one of the main disadvantages of using voltage bias diode clipping circuit is that they need an additional EMF battery source, which may or may not be a problem. One easy way of treating bias diode clipping circuit without the need for an additional EMF supply is to use Zener diode. The Zener diode is acting like a bias diode clipping circuit with the bias voltage being equal to the Zener breakdown voltage. In this circuit, during the positive half of the waveform, the Zener diode is reverse bias, so the waveform is clipped at the Zener voltage. During the negative half cycle, the Zener acts like a normal diode with its usual 0.7 voltage junction value. This is full wave Zener diode clipping. The output waveform from the full wave Zener diode clipping circuit resembles that of the previous voltage bias diode clipping circuit.
For question number 6, explain our results like input and output wavefront. So, for the positive diode clipping circuit, this is the input wavefront and this is the output wavefront. Next, for the negative diode clipping circuit, this is the input wavefront and this is the output wavefront. After that, we move to the clamper circuit. For the positive clamper circuit, this is the input wavefront, and this is its output wavefront. Next, we have positive clamper with positive VR that we will get this input wavefront and this output wavefront. For the positive clamper with negative VR, this is the input wavefront and this is the output wavefront. For the negative clamper, we will get this for their input wavefront and this for the output wavefront. We also have the negative clamper with positive VR and also negative clamper with negative VR that will look like this, their wavefront. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and hi. This video will answer all the 8 questions from the lab manual of experiment 5 multivibrator.
Multivibrator is a device consisting of 2 amplifying transistors or valves, each with its output connected to the input of the other, which produce an oscillatory signal. It works as 2-stage amplifier operating in both stable and unstable mode. In multivibrator, the output of the first stage is given to the second stage and the second stage output is again feedback to the first stage. By this, the cutoff state will become to saturate and the saturated state will become to cut off. For question number 2, this is an example of collateral coupled monostable multivibrator circuit. Let's suppose that in the absence of a trigger pulse and with S closed, initially the circuit is in its stable state with Q1 is off at cutoff and Q2 is on at saturation. If positive trigger pulse is of sufficient amplitude, it will override the reverse bias of the EB junction of Q1 and give it a forward bias. Hence, Q1 will start conducting. As Q1 conducts, its collector voltage falls due to voltage drop across RL1. It means that potential of point A falls negative going signal. This negative going voltage is fed to Q2 via C1 where it decreases its forward bias. As collector current of Q2 start decreasing, potential of point B increase, positive going signal due to lesser drop over RL2. Soon, Q2 comes out of conduction. The positive going signal at B is fed via R1 to the base of Q1 where it increases its forward bias further. As Q1 conductors, more potential of point A approach 0 volt. This action is cumulative and ends with Q1 conducting at saturation and Q2 cut off. Monostable multivibrators are used to trigger another pulse generator or regenerating old and worn out pulses. It is often used as timers, delay circuits, gate circuits, or oscillators.
Question 4. Explain the role of commutating capacitor in a bistable multivibrator. Function commutating capacitor in a bistable multivibrator is to enhance the switching features of circuitry. The capacitors are known as speed-out capacitor. Their function is to increase the speed of the circuit in making abrupt transition from one stable to another stable state. Question 5. Why is bistable multivibrator called a binary? Bistable multivibrator called a binary because it had two stable states and indefinitely retain a specified output state unless an external trigger is used to cause the state to change. Question 6. What is switching circuit? Switching circuit refers to the communication system in which, on demand, a dedicated route with assigned bandwidth is set up before the actual communication can take place. On demand, ensure that when the request is made, the route is configured quickly.
Question number 7. Justify that a stable multivibrator is a two-stage RC coupled amplifier using negative feedback. How does it generate square wave? Answer. The two states of the stable multivibrator circuit between which is switches are those in which the amplifier output is positive and negative saturation. Resistor R and capacitor C provide a frequency-dependent level of negative feedback. At high frequency, the negative feedback is reduced and the circuit will become unstable. Stable is a free-running multivibrator that has no stable states but switches continuously between the two states. From this action, it can produce a train of square wave pulses at a fixed known frequency. Number 8. What is the differences between a switching transistor and an ordinary transistor? Answer. Output current of switching transistor is controlled by the current, and this is also called current control current device, CCCD. But in ordinary switch, the output current we have to control physically. That's all for this video. Thank you.